All right, so chapter 3 here is the polynomial, right? Polynomial and a rational function. So polynomial, actually the linear function is a polynomial, is part of the polynomial. Quadratic equation is also part of the polynomial, okay? And of course, rational function is not polynomial. Rational function, you're gonna have a denominator, okay, with the x. All right, so we're gonna talk the first two sections here is the quadratic equation. Actually, in chapter 1 and chapter 2, somehow we already involved in the quadratic equation in certain way. Okay, so we should be a little bit more familiar about the quadratic equation. We need to be able to graph the parabola, right? And then find the x-intercept, y-intercept, determine the quadratic function, the minimum or maximum, and then the application in here, okay? So what is a quadratic equation? Well, a lot of time, I think people will be remember quadratic equation is this form, right? Is f of x equal to ax squared plus bx plus c. All right, that is the standard form. Okay, and if we write down f of x equal to a times x minus h squared plus k, this one is called vertex form. Okay. We have this parabola, right? And then this one is a vertex. Okay, this one is a vertex. If I write down this form, if I write down in a general form, this is considered a general form, the general format. All right. If I put this in a general format, I do not know where the vertex is. But if I converted this perfect square, okay, we will know the vertex here will be h and k. So what does that mean? If we look at it, if I have a f of x equal to 2 times x minus 3 squared plus 4, right? If I have this quadratic, I will know my a here will be equal to 2. My h here will be equal to 3. My k here will be equal to 4. All right, so basically, I will know my vertex here is in h and k in 3 and 4. And a is 2. 2 is greater than 0. So that means this quadratic is facing up. All right, so I can actually graph this one very easily. So 1, 2, 3. All right, and then 1, 2, 3, 4. All right, so this is my vertex. Look at it, this is my vertex. And then this one is a is greater than 0. So this one is facing up. This one is facing up. Okay, so that is my quadratic equation, my graph, right? So if I have this vertex form, I can find a vertex right away, and then I can find knowing like a is positive or negative, so facing up there, right? So that's very easy. Same thing, this a and a here is the same, all right? But this h and b here is different, okay? Same thing as this one. The only two functions the same here, the common one here is the a is the same, the rest is different. All right, so the vertex form here, a here, when a is positive, this is facing up or open upward, right? When a is negative, this is open downward. So I usually think the positive one like a smiling face, okay? So it's facing up, it's positive one, right? And when this is negative, it's kind of like the angry face, okay? The angry face, all right? So the sad face in here. So that is you negative, okay? So kind of a little bit connection in here, right? And the vertex here is h and k, okay? All right, so how do I find the x-intercept? If you want to find the x-intercept, you need to make y equal to 0, all right? If you want to find the y-intercept, you make x equal to 0, x equal to 0. So you find f of the 0 in here, okay? So that's how you find the x and y-intercept. So look at this one right here. How do I look at this one? How do I graph this one right here? Well, if I convert, this is a perfect square, right? So we know this is in a vertex form. And the vertex form here is a times x minus h squared plus k. Okay, so my a here is -1, which is less than 0. So this one is facing down. All right, and my h here is 1, my k here is 4. So the vertex here will be 1 and 4. All right, and this will be something like that. Okay, this is 1, 2, 3, 4. All right, and this is 1 and 4. Okay, vertex here, and then this will be facing down, facing down. All right, so that is my graph. Yeah, if you want, you can also put in a calculator, put the whole thing in a calculator and graph them. All right. So how do I find my x-intercept in here? Oh, we said that earlier, if I want to find the x-intercept, right? If I want to find the x-intercept, y must be 0. So that means f of x or y equal to 0, right? So we're going to have a negative x minus 1 squared plus 4 equal to 0. Okay, I can add this, move this to the right hand side, so I can let a 4 equal to x minus 1 perfect square, right? So if I want to find the x, I just take the square root on both sides. Take the square root on both sides. Look at that, take the square root on both sides. But you take the square root, make sure you have a plus minus, okay? So plus minus 4, so this one will be x minus 1, right? And then plus minus 4 will be 4 square root will be 2. Okay, so I will add a 1 on both sides. I will plus 1 on both sides. So x will be plus minus 2 plus 1. Okay, so one of the x will be 2 plus 1 or equal to 3, right? The other x here will be -2 plus 1. -2 plus 1, which is -1. All right, so yeah, so you have an x-intercept here. This will be 3, y is 0, and then this one, x will be -1, y will be 0. So that is your x-intercept, right? And then if I want to find my y-intercept, so where is my y-intercept here? My y-intercept here, x will be 0. So plug this negative, 0 minus 1 squared plus 4, okay? All right, so this negative is outside, right? Negative is outside, you have to have a negative. -1 squared will be +1, and then plus 4. So -1 plus 4 will be 3. So your y-intercept here will be 3. Okay, will be 3 in here. All right, so we can put this whole thing into calculator, and then we can check that. All right, so I can plug this whole thing in the calculator. Okay, we have a negative. Remember, negative outside, you have to use a parenthesis. Okay, x minus 1 square, and then plus 4. Okay, we're gonna graph them. All right, we can zoom. I can zoom this one to standard, zoom 6. All right, so now you can see, yeah, I do have this x-intercept in here, right? This is -1, this is 3. So it is exactly the same as we just saw. And then when x is 0, y it is 3 in here. And you can see this one is the vertex. So vertex is in x in fourth quadrant, right? At least you can see the vertex is in fourth quadrant. Both x and y are positive. So x is equal to 1, y is equal to 4. So that will match everything we talk in this calculation in here. Okay, so that is how you find a vertex in this case. All right, you can make a graph in here. Okay, any questions? Anyone? All right, so we're gonna look at the general form. Okay, graphing this general form. If I have a f of x equal to ax squared plus bx plus c, as we said earlier, the a is the same, right? A is positive, open up, A is negative, open down. If you have this form and you don't want to complete a perfect square, you can using this called a vertex formula, not a vertex format, but vertex formula to find a vertex. Okay, so you don't have to complete a perfect square. You can just using the h here. This whole thing, this will be your h and k. All right, your h here will be just using negative b over 2a. All right, your h here will be negative b over 2a. And then you find this one, this is your vertex x, right? And how do you find the vertex y or k? You just plug this x value into the function to find it, and that's it. All right, so let's see if we have this one right here. Okay, so if we have this one right here, look at it. How do I find a vertex? Well, remember we have the vertex formula. This is negative b over 2a, right? And then this is f of negative b over 2a. So you have to find the a. Your a here is negative 1. Your b here is 4, right? B here is 4. C here is 1. This is your c, okay? And then in vertex x is negative b over 2a, and then negative b. B here is 4, 2a. A here is negative 1. Negative, negative become positive, right? And then you have 4 over 2, so that's 2. All right, so your vertex here, x is equal to 2. Okay, how much is your y or h? Your y value will be f of the 2. Okay, your negative b over 2a is already calculated equal to 2. So this will be negative 2 squared plus 4 times 2 plus 1. Okay, and this negative is outside. Okay, this negative don't have a square. So 2 squared is 4. So this is negative 4 plus 8 plus 1, right? So that's 9 minus 4, so that's 5. So your vertex here is in 2 and 5. And this one is facing down. Okay, 2 and 5. And probably somewhere right here. 2 and 5. 2 and 5. All right, this is 2 and 5. And it's facing down. Okay, so that is something like you can find a vertex, this one right here. So you don't have to convert it into the vertex format. Using this one will be much easier. Okay. All right, and if we also want to find a domain and range, right? So domain for the quadratic, it doesn't matter you facing up or down. Domain for the quadratic is always all real number, okay? Always all real number in here. And the y value, you can see this y has maximum, right? This is facing down, so y has a maximum in here, okay? So this one here, this one looks like this one here. This one is 2, right? And then this one here is 5 for this one. Okay, so that's your vertex. All right, so your vertex y is going to from negative infinity up to 5, include 5. So you use the bracket in here. Okay, and this line is x equal to 2. So this line is called a symmetric line. The quadratic is always symmetric, but not always symmetric with the y-axis, but symmetric along passing the vertex. It's always symmetric passing the vertex. And this vertex equation here is x equal to 2. Okay, so that is your symmetric line. And you can also see this on the vertex left-hand side, this is increasing, right? This is all increasing. And after the vertex, it become decreasing. All right? So you can see one part is increasing, one part is decreasing. Okay, how do we find this one right here? Okay. All right, so we have this quadratic function without graphing. Can you find the minimum or maximum for this one? The answer will be yes, since a is positive greater than 0, so this will be facing up. So facing up here, you're gonna have a minimum, right? And then we can find the minimum or maximum. We have a this one is minimum. All right, where's the minimum? Minimum is always on the vertex. Okay, always on the vertex. Minimum or maximum is always on the vertex. So we have to find the vertex in here. So where's the vertex formula? That's negative b over 2a, right? And then you can just remember that's negative b over 2a for the x. So my a here is 4. My b here is negative 16. All right. If I want to find the vertex x, I just need a and b. Okay. So b here is negative 16. A here is 4. So negative become positive. So 16 divided by a is 2. So my vertex x is equal to 2. All right. And how much is y? Well, y, I just need to find a for the 2, right? Plug x equal to 2 in and do the calculation. So that's 4 times 2 squared plus 16 times 2 plus 1,000. Okay. And that is 4. 4 times 4, 16 minus 32 plus 1,000. Okay. So that will be negative 16 plus 1,000, right? And then that will be A4. All right. So my vertex here is x equal to 2. Y here is AA4, 884. All right. And this one is facing up. Okay. Look at that. This one is facing up. So this is the minimum. All right. So that's how you find the minimum or maximum on this quadratic equation. Okay. All right, I want to talk this kind of maximize the area. Okay, so this one is that you have this is an application, right? This is a quadratic equation application. Okay, you have a 100 feet of the fencing to enclose a rectangular region. Find the dimension of the rectangle that maximize the enclosed area. What is the maximum area? All right, so look at the rectangular region. We use this quite often, right? So you can see drop a rectangle in here. We have a length, we have a width. All right, so what is this 100 feet mean? That means you have a 100 feet of material and you need to build this rectangle, and I want to have this rectangle get a maximum area. Okay, I want to as large as possible in here. So now you finish the algebra, right? So how do you do this one? Okay, so this one you have to understand this 120 feet. You have to build the 4 sides. So that is a perimeter. All right. And we said earlier, perimeter here is 2L plus 2W equal to 120. Since they have a 2 in here, I can actually divide by everyone by 2. So I will have my L plus W equal to 60. Or I can solve for L equal to 60 minus W. I'm going to minus W on both sides, right? So I will have this expression. My length is equal to 60 minus W. Now we want to find a maximum area. So what is my area? My area is using length times width. Okay, so this is 2 formula you do need to remember. And I will using this one for my length. Okay, so my area here will be 60 minus W and then times W. All right, we can multiply that in. Okay, all right, so this one looks like a formula. I can write down a negative W squared plus 60W in here. Okay, if you're not quite familiar, I can let A equal to Y and then let W equal to X. All right, so this one is a quadratic equation, which A here is negative 1, B here is 60. So this one is facing down. It's a quadratic equation facing down. Facing down, you're going to have a maximum area because Y maximum, Y is A. Y here is A. Okay, so where is the maximum area? It happens on the vertex. So I'm going to have to go to find the vertex. All right, so my vertex x here is negative b over 2a. All right, negative b over 2a. A here is negative 1. All right, so this one will be 30. All right, so my x here is 30. So what does this x mean? This x here actually is the width, right? We just change this, into y and x, but actually this x here is the width. So your width here is 30. All right, and my length here, my arrow here is 30 minus w 30. So this is also 30. So what does that mean in here? That means your length and width are the same. All right, in order to build a maximum area, you have to build a square, okay? A little bit square, all right? So you have to build a square. This we are giving you the maximum area. All right, you have to build a square. That means length and width are the same, right? And what is my maximum area? My area here is length times width, so a 30 square, right? So that's 900 square feet. Okay, so that is this one right here. That means, yeah, we can use math. We giving you one number, you can find three numbers, right? You can find the length, you can find the width, you can find the maximum area. All right, so that is the application for the quadratic. So now you can kind of understand why we learn the quadratic, because it has this many good uses in here. Okay, any questions? All right, I will talk one more section and that will be it for today. Okay, this will be 3.2 polynomial function and the graph. All right, so that means we using the polynomial. That means polynomial is always have an integer on the power, right? And then we're gonna be able to determine the behavior leading coefficient and the leading term, right? The polynomial, what is polynomial? Polynomial basically is p of x equal to a x to the n power a sub n m minus 1 x to the n minus 1. All right, so this is always x power, always integer, okay? So if you have y equal to x cubed, this is a cubic function. Cubic is also a polynomial, okay? So polynomial always a smooth and also continuous graph. Polynomial domain is always all real number, okay? So if you look at the quadratic or cubic or linear, those are all polynomial, okay? Because these all power are integer. So the domain is always all real number, okay? And if we're looking at the first term, we can kind of knowing the behavior of the graphing. So this is called a sub n and the degree of the n power. All right, so look at this one. This is a polynomial we're talking about, right? A sub n, the coefficient, and x to the n power. This fourth power is very important, because if I have a f of x equal to 2x, this is power of 1, right? So power of 1, we know this is going to be a straight line, okay? But if I have a g of x equal to 2x squared, now I have this n here is quadratic, right? So I know now this is a quadratic. Look at it. So this power, the first term, determines everything, all right? And then if I have a h of x equal to 3x cubed, now we know this is a cubic function, okay? Cubic function, all right? So this first term determines the entire behavior of the graph. Okay, that's what I'm saying in here. All right, so look at this one right here. When a is positive, a sub n is positive, right? This one is always, and then the n is r. N is r. That means r degree. Okay, it can be 1 degree, 3 degree, or 5 degree. When it's r degree, this is always going to two directions. Y go up and then the other y is going down, okay? When you have a positive one, it go through this way, 1 and 3. When you have a negative one, it's kind of going this way, all right? And when this higher degree is an even power, either both facing up or both facing down, depends on the a, okay? So that is this one right here. So you can see this one, we usually call this one is a quartic. okay, a quadratic function, and then this highest power is 4. 4 is an even function, right? And then your a here is positive 1. So this one will be both facing up because this is an even function, even power. Yeah, this is also an even function, but this power is even. All right. So yeah, that is how you look at that. Okay, that is the behavior. So a sub n and x to the n power determine the entire graph's behavior. Okay, zero of the polynomial principle, that means the zero, that means x value make y equal to 0, right? This is called zero. Sometimes we also call like the x-intercept because y is 0, okay? And this one right here, we can find all the zeros for this polynomial. So that means what kind of x value will make this y equal to 0, right? And we can solve this one. We can make this whole thing equal to 0, okay? And then in order to solve this one, we can do a little bit grouping in here. Okay, we can group these two together, and then we can factor these two out. This will be x plus 2. The last two, we factor 4 out, negative 4 out. So this will be x plus 2. Look at that. And then we're going to have a x plus 2. This one is going to have x squared minus 4. Right? X squared minus 4, we can factor into x plus 2 and x minus 2. All right. So we actually have a x plus 2 squared and then x minus 2. So this that means this one is a cubic function. What does a cubic function mean? Cubic, that means this one is up. So this is going to be 1 up, 1 down, something like that. Okay. And then somewhere in the middle. And then when we factor each factor into 0, right? So we have a x equal to negative 2 and x equal to 2. All right. So we have a 0 in here, negative 2, positive 2. Okay. And since this one, positive 2 is only degree of the 1, so this is called crossing. Okay. The graph is going to be cross this point. All right. And then we can go to find the f of the 0. Everything will be 0 instead of this one. So this is your y-intercept. Y-intercept here is negative 8. So basically, in order to graph this one, I can graph this one without a calculator, basically. All right, by using all these characters in here. So I know I have this one right here, right? And I know this is going to this way, okay? So this one, this point, since you have a square, so this point is called tangent or touching. So that means the graph is gonna be something like that. The graph will come back to this point in here and then bounce back. Okay, and then gonna cross this one right here. All right, so that is how the entire cubic, how the entire f of x look like. Okay. So polynomial, actually you can predict the polynomial, or you can draft, sketch the polynomial without using the calculator. Okay, so this is the one I just did. I just sketched this whole thing without a calculator, right? By knowing all these characters, by knowing the x-intercept, y-intercept, and then the power. When this is an even power, that means it's tangent to the point. Okay. When this power, this is 1 power. 1 power is an up power, so that means at this point it's gonna be crossing. So what does crossing mean? This is crossing, right? Y changes from positive to negative. That's crossing. Okay. And what is tangent? Look at this is tangent. When you got here, bounce back. All right. Y stay in a positive. So that's tangent. You can tangent this way, or you can tangent from this way, right? You can tangent this way. So Y stay in a negative. Y stay in a negative. This tangent, y stay in the positive. All right. So tangent is kind of like a touching. Okay. So when do you know it will be tangent? Because this power is an even power. All right. So this is called, in the book, it's called a multiplicity. Okay. So if you have an even multiplicity here, okay, it's called touch the x-axis. All right. And when you have this one is a R multiplicity, okay? So when you have this one is R multiplicity, it called a cross, right? If we look at this one right here, all right, if in a power is a R multiplicity, then the graph will cross the x-axis. All right, so look at this one right here. Can you sketch this one? The answer will be yes, okay, because x equal to -1/2. At this point, this is gonna be tangent, okay, because this power is 2. Power is 2, or R is 2, okay, power is 2, is multiplicity, is even, so that's tangent, okay. X equal to 5, x minus 5, R here is 3, so this is called R power. R power, this will be crossing. All right, so if you have this one, so I can basically sketch this whole thing in here, right? So that's y, that's x. So this power 2, power 5, 3 added together will be power 5. So this is R power. And then coefficient is negative. So you're gonna be from 2 and 4 because coefficient is negative, okay? And then x equal to -1/2. If we say this is -1/2, and then this one will be 5, right? A 5 will be crossing, this will be tangent, -1/2. All right, so this graph, and then on f of 0, so how much is f of 0? F of 0 will be -4, 0 plus 1/2 square, 0 minus 5 cube. So this will be -4. This cube will be 1/8, okay, and then this this square will be 1/4. All right, and 4 and 4 cancel out, and then this is -5 cube, 25 times 5, 125. So this is positive 125, so it'll be somewhere right here. Okay, I'm gonna say this is 125. All right, so this one will be coming here, tangent here, all right, and then come back here, and then cross it here. So that's how the graph look like. Sketch, not quite exact, but you got an idea. You got a pretty much the schedule in here. Okay, so that is this called a polynomial graph. All right, look at this one right here. Okay, so this one x equal to 5, right? This one is a R power, so that's called crossing, okay? And x equal to -1/2, this is called tangent or touching. Touch this one and the mouse back, okay? And the coefficient a is negative, so you can go through 2 and 4 that way. All right. Or if you really don't know, you can really put in a calculator graph them. But I just want to explain like why this happened. It has, sometimes even you use a calculator, you still need to be able to answer this type of question, right? So this one will ask you, x equal to 5, what happened? What kind of behavior does the graph have, right? So you need to know this one at this point is crossing or cross, right? And then at this point is called tangent or touch, okay? The book using touch, so you might just using touch in here. All right, so that is this one right here. You can also find the x and y intercept. Look at this one right here, right? That's another example in here. So this one right here, you have a x plus 2 squared times x minus 3. This is multiplied. So this whole thing, actually, if you cover the 2 here, this will be x squared. You cover the -3 here, this will be x. So you're going to have your leading term, basically your leading term or the fourth term. Your leading term. Okay. This is 2x cubed. All right. 2 is positive, so you're gonna go through 1 and 3, yeah, 1 and 3, and then cube it, so you're gonna have a q1 and q3 right here. All right, and then look at this one right here. When x equal to -2, so -2 right here, right? This is an even power, so this is gonna be tangent. So this is gonna be tangent. That means mouse back. All right, and then when x equal to +3, this is gonna be crossing. So somewhere right here. Crossing like that, going up. All right, so that is this is crossing, this is a tangent. Okay. All right, so that is the behavior of this polynomial. I think we're gonna stop right here for today. Okay, we already in chapter 3, 3.1 and 3.2. And I would say, you want to go ahead, focus on your test 2 for tomorrow first. And after the test 2, you can decide if you want to do the optional midterm or not. Okay, we actually just reviewed the optional midterm earlier. So I will post those video as well. The entire chapter test 2 review was done on last week, right? So you should still be able to find a video that way. If not, let me know.